So this question is from kinetic energy and potential energy. Kinetic energy, and we know that kinetic energy formula is half mv square. Potential energy is equal to mg h. So here it is given that a diver of mass n drops from a board 10 meter above the water surface. Suppose the water surface is this one, water surface, from where reference is taken, and the board is placed 10 meter above. So this is 10 meter. Right? This is the board, and the diver is diving from here. So neglect air resistance. Fine. Find his speed. Find his speed 5 meter above the water surface. It means in the middle. So if suppose he is diving here. So here we have to find his speed as he hits the water, when he is hitting the water. So 2 times we need to find the speed. So here we need to find A, here we need to find B. Now we know that conservation of energy, Conservation of energy says that the total energy which is there initially will be equal to the energy finally also, right? So energy can neither be created nor be destroyed. The total energy will always be constant. Total energy will always be constant. It means kinetic energy at any point of time plus potential energy at any point of time will always be constant. Now what happens generally when in this position, right? Suppose it is A, it is B. At position B, because the person is static, okay, there is no velocity, this velocity is 0. So in this case, here at this position kinetic energy is equal to 0, but potential energy will be maximum, mg h1, right? So this is h, and suppose this is h final, or we can say initial, because from here it is diving, h initial, hi, and this place it will be hf, because the diver is hitting the water surface. Right. So at this point and at this point, kinetic energy will be maximum at this point, okay, and potential energy will be 0. Energy will be maximum at this point. Okay. So the same we will be finding it out. So suppose if we are finding the kinetic energy at this point, h is equal to 5. So we can say that at initial kinetic energy, that is at initial point, kinetic energy was 0, potential energy was mg hi is equal to, now kinetic energy, so we need to find the speed. So at this point speed is there, Okay, so half m, suppose b1, I am putting b1 square plus mg. Now the distance, suppose h1 at that point. Okay, so m, because left hand side, right hand side, m is there, so m we can remove. Okay, right, and we can write half v square, v1 square is equal to g into hi minus h1, which will be given to us as v1 square is equal to 2g hi minus h1, means next step will be, so v1 is equal to 2g hi minus h1 whole root. If we will substitute the value, so 2 into 9.8 into hi minus h1, so hi is 10 and h1 is 5 meter above the water surface, so 10 minus 5, this will be giving us as 5, so 5 into 10 into 9.8, which will become 98, right? Okay, so whole root 98, around 10 meter per second, right? Around 10 meter per second will be the speed. Now in another case, this is for A. Now for B, his speed as he hits the water. Again we will be utilizing this kinetic energy plus potential energy. So kinetic energy, again this one 0 plus mghi is equal to here half m, suppose vf square plus mg. Now h has become 0, so this energy, potential energy will become 0 here. Okay, right, mm will get cancelled, right? So Bf square is equal to twice G Hi. Bf square is equal to 2 into 9.8 into Hi is 10, right? And which is given to us 9.8 into 10, 98 into 2, 196 Bf square. So Bf will be equal to plus minus 14. So minus, it cannot be minus, the speed cannot be minus here. So it is 14 meter per second. So we got this value. And this is the question which belongs to physics and related to energy, kinetic energy and potential energy. Thank you.